So good morning to everyone. So course name Engineering Thermodynamics for Agricultural Engineering. So unit 3 Heat Engines. So myself B. Bharat, working as assistant professor in the Department of Agricultural Engineering, Engineering College. So what is meant by heat engine? So heat you know very well. So it is the form of energy. So engine is a device which is used to transfer the thermal or heat energy into mechanical power or mechanical energy. So mostly this engines is used in automobiles, tractors, tillers, very well. So a gasoline engine is a form of heat engine. So the different types of engines are available: 2-stroke engine and 4-stroke engine. So every engine have a 4 strokes. What are the 4 strokes available? Inlet stroke or intake stroke. Then number 2, compression stroke. Number 3, power stroke. Number 4, exhaust stroke. So one by one we are going to discuss. Intake stroke and inlet stroke. So in this stroke, the piston movement and also the valve position is very important. In piston position, top dead center moves top dead center to bottom dead center. So in the stroke, inlet valve will be open and exhaust valve will be closed. So first, air plus fuel mixers enters into the cylinder. So in this stroke, the top dead center to bottom dead center, the quantity of air plus fuel mixer filled in the cylinder. Number 2, compression stroke. So in this stroke, the piston moves from bottom dead center to top dead center. So in that stroke, the valve positions, inlet valve and exhaust valve both valves are closed. So in that stroke, already filled air plus fuel mixer will be compressed. So initial pressure and initial temperature of air plus fuel mixer will be increased to reach P2 and T2. Pressure P2 and temperature T2. The third stroke, power stroke or stroke. So in this stroke, the piston position moves from top dead center to bottom dead center. The valve positions, inlet and exhaust valve, both valves are closed. So in that stroke, what happened? So during end of the compression, so with the help of spark plug, so we provide the ignition. So at the time, the air plus fuel mixer will be burning. So we can get large amount of heat energy or thermal energy. So due to the thermal force, the thermal pressure impact on the piston moves from top to bottom in very high speed. So we achieve we can get the power or mechanical power, rotary motion. The last stroke, exhaust stroke. So in this stroke, the piston moves from BDC to DDC, bottom dead center to top dead center. So in that stroke, inlet valve closed, exhaust valve opened. So in that stroke, already burned exhaust gases, harmful gases escape from the cylinder through exhaust manifold with the help of silencer and mixed to the atmospheric air. The term efficiency of heat engine. So what is meant by efficiency? So efficiency, one of the technical term. So it is used to refer the performance of that equipment. So efficiency you know very well, output divided by input. So generally in your example point of view, so maximum mark in the course 100 mark. So now the students got 72. So the student efficiency 72%. So what is meant by 72%? 72 is the output mark 72, 100 as the input mark 100. So efficiency is nothing but ratio of output to input. So in that engine, what is meant by output? So output is nothing but net work done. So what is the work output we can obtain from the engine? That is called work output. So input is nothing but heat supplied. So here heat supply is nothing but burning of fuel. So how much amount of fuel will be burned? That fuel has some calorific value. So multiplication of mass of fuel in calorific value can get the heat. We are going to discuss about the Carnot engine. So Carnot engine is an imaginary engine. So this engine is not available in the nature. So Carnot is one of the scientists, Sadi Carnot. So he developed that engine. That's why we are called as Carnot engine. So it is also called as this engine operated by the constant temperature. So what are the different thermal process available in the Carnot cycle. So 2 adiabatic process available and also 2 isothermal process available. So isothermal you know very well. So here the temperature will be remains constant. So change in energy equal to 0. So already you know the formula, delta U equal to m into Cv into T2 minus T1. Here constant temperature process act in the Carnot cycle. So T2 equal to T1, that's why delta U equal to 0. Then another process is available, another 2 process available, isobaric process. Here pressure is remains constant. So P1 equal to P2.